All right, so we're going to talk about our final method of solving systems, which is called the elimination method. I'm remembering that mathematicians are not very creative with their naming. The elimination name will make sense in just a minute. So why are we having another method? It's because that our current methods that we have, we're talking about graphing, substitution, sometimes are easier, sometimes are more difficult. We'll get into kind of picking out the different methods this week. But when is solving by substitution easy? This is what we went over in class. This is a problem that would be easier to solve using substitution. So why is that easy? Because one of the equations already has a variable isolated, so either x or y, or could be easily solved for it. But the main thing is here we see y is alone, so it would be easy to just go ahead and let's substitute in x plus 7 into the first equation. Now, when is it more difficult? Well, if we look at this equation, number one, no variables are solved or isolated. And if we were to, if you want to go through the process of and you actually isolate one of those variables, you're actually going to be involving fractions no matter what. So that's going to make it much more difficult. So we have a new method that we're going to bring in called using elimination. So behind what I'm going to do is I'm going to take, to solve using elimination, I'm going to take my first equation and I'm going to add on to the left side and to the right side. What I have in this second equation is that x plus 4y is equal to -2. So on the left side of the equation, I'm going to add x plus 4y. And on the right side of the equation, I'm going to add on -2. Now, why can I do that? It's because this statement is saying that x plus 4y is the same, is equal to -2. So if I add that on to both sides, in other words, really what I'm doing is adding the two equations together, then I haven't broken any rules. So what I'm going to do is I'm going to add together 10 and -2 will give me 8 on the right side. And now on the left side, when I add together, I'm going to add together like terms. So notice how I line these up with my x's and my y's lined up. 3x and x gives me 4x. And -4y and +4y would give me no y, would give me 0y. So the y's have canceled out. So why is this method called elimination? It's because we're going to eliminate one of the variables. Oh, sorry. Step back. So how am I going to finish this problem? Well, I'm going to solve. So now I only have x involved. I'm going to solve for that variable. So x is equal to 2. Now, to finish off the problem, I could now need to solve for y. So what I would do is I would take that 2, take the new information I have, and I'm going to plug it back into one of the equations. So I'll choose to do the second equation, and it really doesn't matter which one you choose, but 4y equals -4, divide by 4, so y equals -1. So it's that elimination piece. Seeing that I can add the two equations together and I'm going to eliminate one of my variables, that's going to get me through a problem that's not as easily done with substitution. So as far as steps for elimination, the big thing here we want to start with is we are going to combine the two equations and eliminate one of the variables. You're going to solve the equation, you're going to substitute back in to solve for that second variable. So the elimination piece is going to seem a little bit tricky to begin with, but will actually end up being, I think, probably for most people, the easiest method of solving overall. And number 5, the step, check your solutions. So let's take a minute. Why don't you try this equation, solve it using elimination. So pause, and here we go. So I'm going to take the two equations, and I'm going to combine them by addition. Because what happens when I combine them, and so my equal sign stays in the same place, -2 and 14 gives me 12. When I add them, 2y and y is 3y. 3x and -3x, well, those cancel out. So I'm left with 3y equals 12, which is an easy equation to solve for the value of y. So y equals 4. Now to get my value of x, because I need x value comma y value, I'm still looking for the point where these two lines intersect. I'm going to take that 4 and I'm going to plug it in. Now I'm choosing to plug it into the first equation. I'm taking it and I'm substituting it in for the first equation. So there's still an element of substitution in these equations. And I'm going to solve for x. I want you to think of, before you start the problem, and you start seeing, so this is only our second problem, but start thinking, where is the elimination going to occur? What variable is going to eliminate? Because you should be able to pick it out ahead of time. So when I see 3x and I see negative 3x, that's what I'm looking for as far as what's going to eliminate. So your answer here was negative 2, 4. Now how could I check that? Plug those values in, plug that in for x, plug that in for y, and you should be able to get true statements. Make sure you're plugging them in for the right the correct variables. All right, so elimination seems all nice and easy, and when you do your basic practice, it will be. But what if the terms don't eliminate when you add the two equations together? So right now, if I were to add these two equations together, I would get 4x minus 4y equals 8. And I'm really no better off than I was before because I still have an equation with an x and a y involved. So what if your terms don't eliminate when you add them together? Well, what you want to do is pick a variable. Now, it doesn't matter whether you pick x or y. Sometimes it'll be easier to pick one than the other. And you want to say, okay, so I'm going to focus on my x's here. And notice how everything is lined up. My x's are lined up, my y's are lined up, my equal signs lined up, and my constants on the right side here. What if the terms don't eliminate? I want to look at the x's here, and I'm going to say, okay, if these were going to eliminate, what do I wish I saw here? Okay, so I see a 2x in the first spot. What do I wish I saw in the second spot? I really wish the second equation instead said negative 2x. That's kind of my dream situation. So what I'm going to do is take that second equation, and I'm going to turn it using legal algebraic operations. I'm going to turn it into negative 2x. Well, how do I turn it into negative 2x using algebra in a legal way? Well, what I can do is I can take the left side of my equation and multiply by negative 1, and the right side of my equation multiply by negative 1. Am I allowed to do that? Am I allowed to multiply by the same number on both sides of the equation? Yes, I am. So I'm going to make this negative 2x, and I want to make sure that I'm multiplying the entire left side. So the 5y becomes positive 5y, and the 13 becomes negative 13. So now if I look at my two equations, my system here, I have 2x plus y equals negative 5, and I have negative 2x plus 5y equals negative 13. Now when I add the two equations together, so I'm going to add my x's cancel, and I'm left with 6y equals negative 18, and one of my variables eliminated, leaving me the ability to solve for y. So my x is canceled, and I was able to solve for y. So to solve for x, I would take that and plug that back in. So 2x plus negative 3 equals negative 5, and I could solve from there, and I would get that x is equal to negative 1. So the only difference here is if you don't have a problem set up for elimination, then you need to make it set up for elimination. You need to prepare for elimination. That may be involving multiplying one of the equations. So in this case, I needed to multiply it by negative 1. Could I multiply by other numbers? Absolutely. So why don't you give this equation a try? Pause it and try this one. So again, I'm going to look and I'm going to focus on either one of my variables, but I'm going to choose, and if you chose to focus on your x's, that's fine. We want to try and avoid fractions if possible, but I'm going to focus on the y's here. So if this equation says positive 3y, I really wish that this one said negative 3y. So I'm going to take negative 2x plus 3y equals negative 5, and I'm going to multiply everything times negative 1. So you can think about it as multiplying each side by negative 1 or just multiplying the entire equation by negative 1. But that equation becomes 2x minus 3y equals 5. So now my system says 3x plus 3y equals 15 and 2x minus 3y equals 5. So now my y's are going to eliminate when I add the two equations together. So 5x equals 20. Divide by 5, my x value is 4. I'm going to plug that back in to one of my equations. So now I can 12 plus 3y equals 15, minus 12, 3y equals 3, and y is equal to 1. So my answer, 4, 1. Again, my last step should be to plug this in and check it in both equations.